Welcome to KIRKS ToolBox webinar, the ultimate battery upgrade with ODYSSEY batteries. And today we are going to cover why ODYSSEY Extreme batteries have 2 times the overall power and 3 times the service life of conventional batteries, how ODYSSEY Extreme performance batteries provide the reliability, power, and longevity over a regular flooded lead acid battery, and how advanced thin plate pure lead TPPL technology makes the difference. We are happy to introduce our special guest today. Mike Kirkman was not able to join us because he is helping customers with KIRKS solve problems, which is great for that customer. And we have Pete Desch with the transportation, Pete, I've got Peter down here. You are the area manager for the central region of EnerSys Transportation and Specialty Markets. And remember, you can always visit them at odysseybatteries.com. I'm Linda Kleist, your webinar host, and we have Abby Thompson on technical. If you have any technical issues, please let us know in the chat. And we also want to be available to answer your questions. That's the benefit you get being here on the live webinar. And we'll have a Q&A at the end, so you can add your questions in the Q&A tab. You'll see that below in your toolbar. We want to introduce Pete. He has an impressive 24 years of dedicated sales experience within the transportation industry. He brings a wealth of knowledge and deep understanding of the sector. Currently, Pete is serving as the Central U.S. Area Manager with EnerSys, a global leader in stored energy solutions for industrial applications. Pete is at the forefront of advancements in transportation power, and his career has been primarily focused in B2B sales with a significant emphasis on the heavy-duty and off-road markets, which is perfect for us today. Pete, we're looking forward to learning more about the unique features of ODYSSEY batteries.
Thank you for the introduction. Yeah, I appreciate it. So we'll go ahead and get started here. Here we are. I have control of the screen. So I guess where I wanted to start off was to kind of introduce who EnerSys is. We're the manufacturer of ODYSSEY batteries. As you can see, we're a fairly large company, about $4.2 billion in sales in fiscal year 2025. That being said, we just want to make sure that you know that we're not some fly-by-night company. We've been in business for many, many years and are going to be there to support the product throughout our warranty period, as well as continue to develop new technologies for the variety of markets that we serve. Primarily, we're going to be talking about what we do in the transportation market. So a big portion of our business is the heavy-duty truck market for commercial fleets and first responders, various other transportation types of applications. Also within our organization, we build batteries, stored electrical energy solutions for a variety of other applications, data centers, the grid. We do some military business. The whole point behind that is we develop different technologies, different chemistries for different applications, and then we share that knowledge within our company to learn the things that some of our counterparts are doing in other divisions, and then apply that to this market. So why ODYSSEY battery? Well, maybe the place to start off with is understanding what a battery is and how it works. So in essence, a battery is a passive electrochemical storage device, as it says right there on the screen. And the way that it operates is there's basically a positive and a negative plate. That positive and negative plate are in a electrolyte solution, which some people call battery acid. And that's pretty much how all batteries operate across the board, regardless of the technology. There's a variety of other chemistries. There's lithium, which is probably the most popular that everybody's heard of. But today we're just going to focus in on lead acid batteries, as that is still the most common within the industry. So kind of to deep dive a little bit more into how lead acid batteries operate. I'm going to give you, some information here on this on this chemical equation, but basically what it shows is there's a positive plate which is made of lead oxide, and there's a negative plate which is made of gray lead, and there's a paste that's used. Those are placed on these lead grids, and then those plates are stacked up together, and they're inserted into that electrolyte, that battery acid, which is sulfuric acid and water. The way that a battery works is when you discharge the battery, that lead oxide and lead combines with that sulfuric acid and water. It converts that lead oxide and lead to lead sulfate and water. And then when you recharge the battery, the reverse happens. That lead sulfate changes back to the lead oxide and lead, and then recombines that sulfuric acid, so you have that solution in there. And that process goes back and forth as you discharge and recharge the batteries. One thing I want you to remember, though, is please remember that lead sulfate, as we go on with the presentation. That's an important part of what we're going to talk about, and why our batteries operate the way that they do. So when plates are new, they are hard. The grids themselves, the paste itself is hardened on there, and then as a lead acid battery is used, as it goes through that process of discharging and recharging and discharging and recharging, that material has a tendency to soften up, and that's one of the downsides of some of the other technologies that are out there, is that that softening in those plates occurs, and some of the active material starts coming off of that. So when I talk about active material, what you see here is basically a picture of a grid. So that's a lead, and sometimes lead calcium or lead alloy grid, and that stuff that I showed you before is that paste that goes onto these. The oxide is actually the operational part of the lead acid battery. The grids are simply there to act as almost like wires. They're what conducts that current, what allows that current to exit and re-enter the battery when you're charging and discharging. And there's a different type of battery for different types of applications. So typically what you'll see in this market is a standard SLI battery, or starting, lighting, and ignition battery. That's your high cold cranking amp battery that's designed to start your engine and then power some of the accessories that are inside the vehicle. The other side of it is deep cycle batteries, and those are typically designed for cycling applications. So your golf cart, the trolling motor on your boat, a variety of other applications where it's just asking for energy. It doesn't need that high rate discharge, that cold cranking amps that typical batteries in the transportation market use. So there's a variety of different types of technologies in the lead acid battery market. The first and the most common is flooded lead acid batteries. These basically take those positive and negative plates. The plates are stacked up together, as you can see here in the lower left-hand corner. And then the case itself, which is shown in that upper left-hand corner, is filled with acid. That acid starts that chemical reaction occurring. Then the battery is formed, which is what we refer to as the initial charge on the battery. And then the battery sits there. This is your typical low cost, battery that's out there. And the thing to remember is specifically when you're looking at flooded lead acid batteries, you're either looking at a starting battery or a deep cycle battery. Now, there's some manufacturers that produce a dual purpose battery. The thing to remember with that is they're giving up a little bit on both ends. They're giving it a little bit on the cold cranking amps, and they're giving up a little bit on the cycling capability to kind of find that middle ground while still keeping that low initial cost in play. Those are for fairly light duty applications, and so in the trucking business, it would be the over the road driver that hops in his truck, starts up the engine, puts in his 8, 9, 10 hours, and then turns off the truck and goes into the hotel room for the night. Where there's higher demand on the battery from a cycling standpoint is kind of where AGM batteries come into play. So they are more often than not a little better cycling than your traditional flooded lead acid battery. They are maintenance free, although even flooded batteries nowadays are maintenance free, or what we refer to as maintenance impossible, because you can't access the inside of the battery. But they do perform a little bit better in cycling applications. They are a sealed product, so they are non-spillable, and what AGM stands for is absorbed glass mat. And all that means is you have those positive and negative plates inside the battery, but rather than the acid just being poured inside there to start that chemical reaction, the acid is actually absorbed, or the electrolyte is absorbed into this glass mat material. And that's in that lower left-hand corner there. And it absorbs all that electrolyte, and then it controls that chemical reaction and the way that it occurs inside that lead acid battery. So it has a little bit higher initial cost on there, but the reason people use these is because there are more demands from trucks and a variety of vehicles out in the marketplace, where not only is the vehicle being used to start up the engine, but it's also using power to possibly operate a refrigeration unit on a trailer or a lift gate, or maybe on the truck itself. There's a variety of accessories on there, telematics. It could have a high duty cycle because of the preheat cycle due to the emissions components that are on engines. So again, the battery is being asked to do more than just deliver high energy to start up the engine. It's being asked to cycle a little bit better. This AGM batteries are typically going to have a little bit higher initial cost, but typically that battery is needed for that dual purpose cycling starting type of application. Um,
Pete, before
yes,
you move on, can you go back to that slide? Just a quick question.
sure.
The absorbed glass mat, I missed that. Is that unique to Odyssey batteries? Is that a
It is not. It is not. It is a technology that's available across the market, and EnerSys was actually kind of the progenitor of AGM technology. You'll see in on the bottom there, there's a cyclone battery.
Mhm.
That's a spiral wound technology, similar to what other manufacturers use in their manufacturing process, but it is. It is a fairly dated technology. Again, it was developed in the 70s, but we believe that we've made vast improvements on that battery through our manufacturing processes, our engineering, and developing the technology.
Very good, thanks.
Yeah, thanks. Right. So the next thing we step up to is our thin plate pure lead acid batteries. So that is the Odyssey brand. Again, developed in the late 1980s, and the big differences in our product is the way that we manufacture our batteries. So the primary thing that we do is we use pure lead in our manufacturing process. And the reason that we do that is when you look at the other technologies that are out there, and this is not to say that any of those batteries are bad, that they're defective, that they're not right for your application. They may very well be, but when you have a truly high duty cycle, dual purpose type of application, like you find in some of the EAPUs, that's the electric APU units, basically battery powered air conditioners. When you look at duty cycles of delivery vehicles, where the battery's being, asked to start that vehicle multiple times and possibly get drawn down as that vehicle maybe sits at a dock or at a delivery location. That's kind of where our battery comes into play, is those true dual purpose high duty cycle types of applications. So the reason that we focus in so much on using pure lead in our manufacturing process is when you put dissimilar metals into a corrosive environment, what you get is galvanic corrosion, and basically what that is the battery starting to degrade. So in the other technologies that use alloys in their manufacturing process, what you'll see is fairly low shelf life, and the reason for that is you're accelerating the chemical reaction that's occurring, right? You're converting that lead oxide and lead to lead sulfate faster than you are in a pure lead type of application. It's again, it's not because the battery's bad. It's just it's designed to achieve certain things, typically a lower price point, and still provide the type of performance that you need. But where you have truly high duty cycle applications, thin plate pure lead is really the better option. And another very important thing to note here is that low internal resistance. And I'll talk a little bit about that as we get through the rest of the presentation here on why that's so critically important, and how we achieve that.
You keep jumping so fast. Can you go back to that last slide?
Sure.
I'm sure there are people that totally get all of this, but just in case, can you
Yep.
talk about the traditional versus the TPPL, those two images right there?
Sure. Sure. Yeah. 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 So traditional is basically that previous slide that I had where it's traditional AGM batteries. We'll talk a little bit about the specifications of the battery, but the way that you get higher cold cranking amps out of a battery, a lead acid battery, is you put more plates in there. The more plates you have, the more surface area that you're going to have, which means more active material. So when you put a load on the battery, meaning you turn the key on your vehicle, that battery is going to deliver as much amperage, as that particular electrical system is asking for, right? So again, because we have this pure lead technology, and because of the compression that we use inside of our battery during our manufacturing process, we're able to get that low internal resistance, and that low internal resistance, along with that high plate count, is what allows that battery to deliver much higher cold cranking amps than some of the other traditional AGM batteries that are out there. So when we meet traditional, we're really referring to other manufacturers that use alloys in their manufacturing process. Does that make sense? Answer the
Yeah.
question?
Yes, thank you.
All right, great. So again, thin plate, pure lead. The real upside to our product is goes beyond just the high cold cranking amps. So when you look at other manufacturers that are out there, typically they're going to have a 900 or a 925 or a 950 or even 1,000 cold cranking amp battery that's out there. When you look at some of the dual purpose batteries that are out there, they're going to range from 700 to 800 cold cranking amps, and that's how they achieve that dual purpose technology. When we look at our product and our specifications on our batteries, our ODYSSEY Extreme battery has 1,150 cold cranking amps. It has a 220-minute reserve capacity, which means a much longer runtime, but it's also able to deep cycle like you would on that golf cart or trolling motor type of deep cycle battery, all in one package. And 400 deep cycles is kind of a relative term, right? So a typical lead acid battery, even some of the deep cycle batteries that are out there, can only achieve about 100 to maybe 150 cycles at that 80% depth of discharge. Our battery is rated up to 400 cycles at 80% depth of discharge, and that's important when you're looking at dual purpose types of applications where, yeah, you need all that starting power, especially when you're up north and it's 20 below zero. You need a lot of energy to start up that big diesel engine. But as that truck runs down the road and it's making multiple stops and discharging and recharging the battery, that's where that deep cycling comes into play. And so we're able to accomplish both things in one battery, both that cycling capability as well as those very high cold cranking amp ratings, to meet the needs of our customers and their applications. There we go. So here's just an example of some of the testing that we've done with our product, and kind of gives you an idea of how that thin plate pure lead compares to some of the alloys that are used in the manufacturing process. And so, like I said before, what you'll see with some of those traditional, lead calcium types of alloys that are used in AGM as well as flooded batteries is that corrosion that occurs, and that's basically what's being reflected here. So what we did is we did an extended life test. So we basically test the grids, we test the battery, and then break down the batteries to see what happens to the grids as that battery gets discharged and recharged over a period of time at elevated temperature, right at 55 C. So basically what this shows you is that that lead calcium battery, those grids really start to deteriorate as that battery gets cycled and is exposed to that heat. When comparatively speaking, at 400 days, our grid remains intact. And if you remember when I was talking about how that battery operates with that paste material on there that produces the energy, and then that energy gets transferred to the outside of the battery through those grids. These grids are the wires, right, that are allowing that that energy to exit and enter the battery. If the battery looks like this, if the grids on that battery look like this, obviously you're not going to get a lot of current, electricity flowing through those grids, and that's one of the ways that our battery outlasts some of the other batteries that are out there.
That is impressive contrast. That,
Yeah, it is, and again, it's not
wow.
putting the other guy's battery down. It's just a different technology. It's, you got to use the right tool for the right job. That's what we try to get across. So we'll talk a little bit about where this particular tool is needed later on in the presentation. We're going to jump through a couple of these things again. Our engineers do everything they can to develop a product, and then our manufacturing plants do what they have to fulfill that. But these are just some of the things that we do in our manufacturing process to make our battery last as long as it can in a variety of heavy duty applications. We use epoxy bonding on the inner cell connectors, which are right in here. That's all designed to give superior vibration resistance. We also use compression. So when we stack these positive and negative plates, those plates are compressed together and then inserted into the cell itself. That compression helps hold that active material on those plates and grids, and that extends the life of the battery. We use compression rings and all this to seal up the battery. So when the battery does get exposed to high rates of current and voltage, the battery does not gas out externally unless it's really extreme conditions, meaning extremely high voltage going through that battery. So these are all the design characteristics of the battery that allow it to achieve all the performance features that we want it to. This just highlights that top design. As I said, these boxes here show where those inner cell welds are occurred. Those are over the partition type of weld that we do on there. It's important to note that we do use that epoxy in there because we're doing whatever we can to basically bond all those plates and all those cells together to help with the high vibration that we see in heavy duty types of applications where they experience high vibration either from the roads or from decoupling trailers, all the stuff that Class 8 trucks see out in the field. So this is our premium product. It is the ODYSSEY Extreme battery, and again, this is a 1,150 cold cranking amp battery. It's got 220 minutes of runtime. We call that reserve capacity, and again that 400 cycle at 80% depth of discharge rating. This is the top performing battery that ODYSSEY offers in our product line. It's going to have the highest warranty on there, meaning it has a 4-year free replacement warranty for a variety of different kinds of applications. So sometimes other manufacturers will take a Group 31 battery, but if it's used in a high duty cycle or in a heavy duty environment, a commercial application, sometimes those warranties are cut down. We offer a full 4-year warranty for those types of applications. And then we have our performance series of battery. This is a slightly lower price point battery. Uses the same TPPL technology. We make some changes to the overall design. We reduced the plate count, so we only have 925 cold cranking amps, which is pretty typical for a lot of the Group 31s that are out there. It's got a 200-minute reserve capacity, but still has that 400 cycles at 80% depth of discharge, for those applications. So again, a lower CCA rating than the Extreme, but certainly still a premium as far as battery ratings go out there. So again, the whole idea behind the design of this was to provide a slightly more cost-effective solution than the Extreme series of batteries. And one thing I want to note here when we start talking about battery technologies, and this is oftentimes a kind of an unknown thing, or the way that batteries operate is again, they go between lead oxide and lead to lead sulfate and back and forth, and the reason that you sometimes see low life in batteries, in our industry, we see that 80 to, around 8, maybe 90% of the batteries that are returned for warranty aren't actually warranty batteries. This goes for us. This goes for other manufacturers across the board, and the primary reason for failure is a discharged battery, and so folks that are in the industry, they'll hear that this battery is bad because it's sulfated, and that takes us kind of back to that little chemistry lesson that we did. Is a battery that's sulfated is not necessarily, it's not bad. It's not a manufacturing defect. There's nothing wrong with the battery. Basically, what happened is the battery was converted from that lead oxide and lead to lead sulfate. And because it wasn't reconverted, meaning the lead sulfate has been reconverted back to lead oxide and lead, it stays in this sulfated state. And what happens is that sulfation starts to crystallize on those plates. And ultimately what happens, other than that grid deterioration that you saw on there, is you develop crystals in there, and those crystals cannot conduct electrical current. You're not able to reconvert that lead sulfate back to lead oxide and lead, and that's ultimately the problem. And the challenge with a lot of the other technologies is again, because they're designed to achieve a certain price point. There's some design differences in their product, and what those result in is a higher internal resistance in the battery. So all these things that we talked about, all the features of the battery, all the large welds and all the sealing and compression and all that sort of stuff, is basically designed so that the battery operates as efficiently as it possibly can, and that is reflected in that low internal resistance. So what that means is, in a heavy duty application, let's say it's a delivery type of vehicle, what you'll see is a battery getting discharged throughout the day, right? Every single time that delivery truck stops, turns off that engine, but maybe leaves the key on so that the telematics are operating, it's slightly draining that battery. It's slightly taking that lead oxide and lead and converting it to lead sulfate. And as that goes throughout the day, you get more and more lead sulfate that develops in that battery because it's not being fully recharged. Why is it not being fully recharged? Well, it's because that battery has a fairly high internal resistance as compared to our thin plate pure lead technology. And because of that high internal resistance, the biggest battery charger that's out there is right on your truck, right? It is your alternator, and that alternator is designed to recharge that battery. However, if the battery cannot take all the current that battery is outputting, it's never going to have an opportunity to fully recharge. So a typical Group 31 battery is what we call a 100 amp hour battery. And so in that same delivery vehicle type of scenario, um, if you take, let's say, not a lot of energy, you take 10% of the energy out of that battery. So you've taken 10 amps out of that battery. Um, in order to convert that lead sulfate back to lead oxide and lead, you have to put 10 amps back in. You got to recharge the battery 100%. Well, because of the high internal resistance, oftentimes you're only able to charge that battery at about 5 to maybe at the high end 10 amps. If you charge beyond that, it gasses the battery out. It could cause some damage because of the heat that starts to build up, again, because of that high internal resistance. The secret behind our technology and everything that we do is that low internal resistance. So in that same scenario, when you take 10 amps out of our battery, because we're not limited by that high internal resistance, you can charge our battery with 20, 30, 40, 50, up to 100 amps. And what that means is in that same scenario where you have to put 10 amps back into that battery, maybe that drive back for that driver back to his terminal is only about 20 minutes. Well, you need an hour, right, to recharge the battery because it can only take 10 amps. But with our technology, because you're able to put in a much higher amperage, you're able to quick recharge our battery. You're able to convert that lead sulfate back to lead oxide and lead, and now you have a fully recharged 100% state of charge battery. That's really what makes our battery last as long as it does. And that's really the big difference in our technology over a lot of the other manufacturers that are out there. It's the right tool for the right job. Um, our batteries are all manufactured primarily for the transportation industry in the U.S. So we've got 3 manufacturing facilities in Missouri. We've got 1 in Warrensburg, 2 in Springfield. There are a couple of the small sizes, as well as our very large commercial 4D and 8D batteries that are manufactured in Europe. So the smaller batteries are made in our Newport, UK facility, and our large 4D and 8D batteries are manufactured in Arras, France. But the overwhelming majority of the batteries, particularly for this market, are manufactured in the U.S. And we're pretty proud of that, right? We keep all of our manufacturing stateside, and particularly in this day and age of tariffs. I don't know if anybody's heard of tariffs at all. We picked up a
Yeah.
paper. That's certainly a big cause for concern. The batteries that we manufacture in the U.S. do not have those huge tariffs that we see in many of the other manufacturers that are out there. This is kind of an eye chart, a big kind of a schematic, but basically what it outlines is how our batteries fit into the various types of applications and the technologies that are out there. But again, the long and the short of it is our battery operates more efficiently because of all these technologies, because of the way that we manufacture the batteries using thin plate pure lead, the brass terminals, those large over the wall connectors, the thin plate pure lead in our grids and the cases that we use in our product. Again, all those things are designed to provide a much longer lasting battery for the heavy duty marketplace with the longest warranty. It's not flipping on me here.
That's great.
There we go. So we, in our design process, we also need to validate, some of the requirements that we find out there, and so there's a variety of tests that we run our batteries through to make sure that that we do in fact last within these heavy duty applications. And this is just a list of some of those tests that we run within our factories and our labs to assure that that the battery is going to last within the highest heavy duty applications. As you can see, a lot of focus on vibration. Obviously, there's a lot of vibration in Class 8 trucks. And so we do a lot of testing and development when we were developing this technology. Those last two tests on there are the cycle testing tests, right? So it's a Japanese industrial standard. That's what JIS stands for. It's a cycling test, testing our technology versus other. And then SAE J2185 is another cycling test. That's that extended that extended life testing that we do, where we elevate the temperature in the cycling environment. That's where those grids pictures came from, as far as how the battery operates within a high cycling, high heat environment. So here's the top 10 reasons to buy Odyssey batteries. This is my obligatory marketing guys slide. But really, the biggest reason to buy Odyssey batteries is to provide you a solution for low battery life, right? So where's the sweet spot for Odyssey batteries? If you're getting 3, 4, 5 years, out of your Class 8 truck battery, you're probably not going to want to talk to me, right? There's not really anything that we can provide you that's really going to make sense from an ROI standpoint. The sweet spot is for the fleet or the owner operator that's getting a year and a half, maybe coming up on 2 years, is where it makes sense, where the ROI is there for our product. Again, the way we achieve that is by allowing that battery to get recharged as quickly as possible within that application. It reduces overall maintenance costs. It reduces downtime, or the opposite of that is increases uptime in those heavy duty fleet applications. And then we stand behind that with the industry's best warranty. And with that, I'd like to open the floor to any questions that may have come across during the presentation.
Yes, Pete, we did get 5 questions here.
Okay, great.
No, it's funny with that last slide, you said this is your marketing slide, but those are 10 impressive reasons. They're not it's not fluff. So
no, it's not. It's not. I mean, it all goes into it, but ultimately, for the fleet operator, for the owner operator, the biggest, most important thing is that when they, start their day, whether it's a morning shift or running at evenings, that when they turn that key, they want it to go vroom and not click. And as long as we can, continue to help with that scenario, we're going to continue to grow within the marketplace.
That's great. Well, here's our first question. How do extreme changes in the weather impact batteries in transit vehicles?
Yeah, that's actually a good question, right? So what a lot of people notice is that, especially up in the northern climates where we live here, is you see a lot of battery failures occurring in that November, December timeframe, right? When temperatures start to plummet. And so people assume that it's, the cold weather is what's killing my battery. Well, it's actually the opposite. When your batteries is exposed to high temperatures, particularly down in the southern climates and stuff like that, where you see 100, 105, for extended periods of time, or even in the Midwest here, where you're getting up into the 90s inside an enclosed battery box. Those batteries are actually getting damaged from that heat, just because it's an electrochemical process that occurs inside the battery. So if you think back to chemistry's 101, if you have a chemical reaction that's occurring, and you apply heat to that heat is a catalyst. It accelerates that chemical reaction and more quickly degrades that battery. So the extreme temperatures, really what you're seeing is the heat and how that affects the battery, during those summer months. And then that damage that you're seeing occurring in the battery is brought to light when it gets cold, and diesel engines are harder to start. The battery's not operating as efficiently. Everything is being pulled on the battery, and the damage that's occurred to the battery during those hot summer months comes to light when it's asked to operate in those cold winter environments.
Okay, a related question then on the demand on the battery. What can we do to extend the lifespan of the batteries in our fleet?
Yeah, absolutely. So the obvious answer is use ODYSSEY batteries, right? But but preventative maintenance is absolutely crucial, regardless of the technology or the brand of battery that you're using. You have to make sure that your batteries are getting fully recharged. So going through during your PMs, testing the batteries, making sure that they're fully charged. A fully charged flooded lead acid battery is about 12.65 volts. Our battery is a little bit higher. It's about 12.8, 12.82, 12.83 volts when it's fully charged. But it really is preventative maintenance. So not only checking the battery though, but going through and doing voltage drop tests as part of your maintenance practices, making sure that the alternator is not working too hard because maybe there's some voltage drops in the cabling, and testing that entire electrical system. That it's really important that everything operates as efficiently as possible within those systems. That's going to extend the life of your batteries for sure.
Okay, perfect. We got another question. Actually, it's all we had 5, we have 6. With a fully discharged AGM, do you want to charge that battery on the bench at a low amperage setting to revive the battery?
On a traditional flooded or a traditional AGM battery, yes, you wanna charge that battery low and slow. It's like barbecue, right? You wanna just apply the recommended amount of current. Again, it's about 5 to 10 amps. And then it could take, you know, 12, 14, 18, 20 hours to get that battery back up to a full state of charge, depending on how deeply discharged it is. Um, Again, getting back to what we talked about, our thin plate pure lead technology, you can cut that time in half or a quarter or by 80%, depending on how much current you're going to put back into our battery. So again, because our battery has low internal resistance, you are able to fast charge our batteries. So putting in 25 amps is actually where we recommend you start to fully utilize the technology, right? And make sure that battery gets fully recombined, fully recharged. Um, Oftentimes, if you do have a discharged battery, we like to look and say, okay, why did that battery get discharged, right? Even the lowest cost battery that's out there, it's not garbage, right? There's no garbage batteries out in the market. Those people have that stuff. You go out of business building garbage batteries, right? It's just again a different tool for a different job, and so um, again, when I see a discharged battery, the question is, well, how did that happen? Did something get left on, or is there something wrong? Is there corrosion on my cables that's causing a voltage drop that's not allowing that battery to fully recharge? Making sure that that electrical system is sound so that you're not just replacing a battery and then 6 months down the road, you're going to have the same problem again. And typically, when we look at these heavy duty applications, trucks don't break down in the shop, right? They're always out on the road. And so in addition to the expense of replacing the battery, now you've got road service calls and downtime, which is costing you money. So PM is really important, and making sure that when you do have a discharged battery that needs to get recharged, you need to determine why that happened in the first place so you can correct that problem.
Great, thank you. Pretty thorough answer.
Thank you.
Okay, so we have time. Yes, we got time for more questions. Will the high cranking battery damage the starter?
Yeah, so I've heard it, making calls out in the field where people are concerned about all that amperage and everything else. A battery is passive, so it doesn't push out energy. It delivers energy when there's a load put on it. So it's not a push that's coming out of the battery. It's a suck from whatever is drawing on that battery. So a battery will not damage an alternator. It will not damage a starter. It is merely, again, a passive chemical device that delivers the energy that it's being requested. Our battery outputs 1150 cold cranking amps, or for the first 5 seconds, 2150 amps. But it will only deliver the amount of energy that it's being asked to deliver.
Okay, good. Another question. So this question, how do these compare to other batteries in cost? I think you covered that through the webinar with the engineering and the quality and materials. But
For
how do
sure.
you answer that? How do these compare to other batteries in cost?
Yeah, it depends on what you're comparing it to, but normally we say it's about 1.5 to 2 times the cost of a traditional AGM battery. So a little bit higher than that when you're comparing it to a flooded lead acid battery. Again, it is an ROI, meaning this isn't a niche product that only a few people out there are using for specific specialty types of applications. Some of the largest fleets in the entire country have opted to go with our technology. So fleets like Penske, like JB Hunt, like Walmart, the list goes on and on and on with these large, national fleets with tens, maybe hundreds of thousands of vehicles that are out there, are operating using our battery.
Well, it might have something to do with these 10 reasons too.
It
So,
sure does. It sure does.
okay, last question that we have. What do you do for all electric buses?
Yeah, actually, people don't normally consider lead acid, right? It's the lithium, it's the big lithium battery that drives the bus and everything else. However, there's a lot of components on that vehicle that are 12 volt, components. They're 12 volt DC components. So a lot of the lighting and everything else. Basically, what we do is we provide auxiliary power on our battery. So there's a variety of bus manufacturers when we're talking about transit buses and stuff like that, and as well as our development with some of the largest OEs, truck manufacturers out there, are also utilizing our battery as for auxiliary power in some of their all electric vehicle designs. So there's still a place for our battery in there, but it's really being asked to be more of a cycling type of battery. So that same Group 31 that's starting up your diesel engine is the same battery that's going into those electrical vehicles to electric vehicles to power all of the auxiliary components that are within that application, as well as safety. So there's some work that we've done in the autonomous segments, and so all that autonomous is powered by the 12 volt side of the vehicle, and the reliability and the battery's ability to get cycled up and down very efficiently and still provide reliable power is being used in those applications too.
Perfect. You can tell you know your stuff. That was our last question.
Thank you.
Yeah, it is really important that KIRKS, the KIRKS is the partner for parts. And part of that in the KIRKS toolbox is bringing experts right out where we can talk and ask questions and get people the information they need to keep our world moving. So we appreciate that, Pete. We also want to let you know if you have any questions that did not get answered or you would like a quote, make sure that you can email sales@kirks.com. You can give us a call, visit our website, kirks.com. And the recording of this webinar will be emailed to registrants It's going to be available on KIRKS YouTube channel and in our KIRKS monthly news. So there's a QR code on the site. If you're not getting our KIRKS monthly news, we keep you up to date with industry news, product developments, and letting you know about information and events like this. So sign up on our website with that QR code now. You won't want to miss them. And lastly, the KIRKS team would like your feedback. So if you want to shoot us an email of things that you're looking for, things you want to hear about, we'd love to know what is interesting to you. We appreciate, Pete, you coming on. It's been a great webinar.
Thanks for the opportunity.
A lot of great information on ODYSSEY batteries. And we want to thank all of you for joining us. And you'll be able to catch this recording. KIRKS really wants to help you escape the parts trap, navigate parts that are going to be a good fit for your application. And we have the approved equal seal that lets you know that anything that KIRKS is shipping to you has that approved equal, and we can find out more about that on our website. Call and talk with the KIRKS product specialist today. Thanks so much for joining us. Bye-bye.
Bye-bye.